clean architecture in TypeScript. Have you ever heard about it? Well, I have, and I've studied it for the past 2.5 years. Yet there isn't really a good example of clean architecture in TypeScript, so in this video we will be covering the bare essentials of clean architecture. Well, what do you need to know before we get started? You need to know dependency injection, data transfer objects, the idea behind request and response models, which is very close to DTOs, layers, and TypeScript. Before we get started, first my experience. 2.5 years ago, I started studying clean architecture because I watched a talk of Uncle Bob on YouTube where he talked about clean architecture, and it really hooked me. So I ordered his book, even though I never really read books back then, and I started reading it. And there were some really interesting topics in it, but it still didn't really cover clean architecture. Like there were some added principles, some ideas, and there was a diagram that was supposed to be like, here you go, this is clean architecture. But there wasn't really an example using that diagram. So I started digging more and I started to realize that no one really knew what clean architecture was, which kind of led to this video, because it's the idea is so abstract that there's so many implementations and the book doesn't really cover it. His own blog doesn't even really cover what it means. So I'm hoping that this video actually gives you guys some skeleton to work with. In this video, I will also be utilizing class syntax because later on we will do a live coding session. But you don't have to, right? Because with functions you can do most of the stuff that you can also do with classes. So we will be looking at dependency inversion principle, which is very important, interface adapters, the modern take of clean architecture, main component, testability, component principles, the similarity between clean architecture and hexagonal architecture, vertical slice architecture, which is mentioned in this book, my thoughts and misconceptions, and then we will dive into the live example. Dependency inversion principle, the principle from Solid. It's one of the only principles that I still use today, because it's a principle that makes most architectures actually work. But what do I mean with that? Well, if you look at the left side, we have a service that depends on a repository. Now, what do you mean with depends? Well, it depends on a concrete implementation of repository. If I were to replace that repository with something else, then I would also have to change something in service, because this service depends on this repository and its contracts. By contracts, I mean the input and output, and also the method name. So let's say we have a repository, car repository, and this car repository has a method save. Well, this repository takes in an argument, car, and it returns void. But let's say I wanted to use a different repository. Now in this different repository, it would also be a car repository, but it wouldn't take in a car object. It would just take all the properties of a car, and it would return its ID. Now the service uses a different repository, but it doesn't work because the contract changed. This is something we try to eliminate with dependency inversion principle by making the service depend on a contract. So if you look at the right side, we've moved an interface in between service and repository. The service depends on iRepository. iRepository defines the contract. So in this case, it could be a repository should have a save method. It should take in a car argument and it should return the car ID. Okay, cool. Now this repository on the bottom also depends on its repository interface. This means that this repository actually needs implemented, and by implementing I mean it takes in that interface and it needs to actually implement that save method as stated in the interface. This way, if we decide to change the repository, then the service doesn't need to change because the contract is still stable. iRepository defines that contract and it will never change unless the service wants something different. And this is the beauty of dependency inversion principle, which enables a plugin architecture, which is very, very important around clean architecture. Interface adapter. Well, Uncle Bob really likes giving weird ass names, because this really confuses me as a developer. So to keep it simple, the idea behind an interface adapter is the same thing as we just saw with the dependency inversion principle. If you look at the diagram on the right, you can see that we have an iCar repository, which is the green one on top. And this iCar repository gets implemented by Prisma car repository, right? And this Prisma car repository uses a car entity, which comes from our domain layer, and it uses a Prisma car. And the idea behind this Prisma car repository is to make the translation between the car and the Prisma car. So a car in your domain could have an ID, which is a number, but for performance reasons or whatever in your SQL database, you could say that the Prisma car ID is a string. So that's the idea behind this implementation of the repository. This also means that the Prisma car repository is responsible for making whatever database you're using, well in this case Prisma, work with the iCar repository interface, which makes it therefore pluggable. That's the whole idea behind an interface adapter. Now, if you look at the very original intent of IncoBob, you might actually want to implement interface adapters differently, but I'm not going to get into that one, because in my opinion it's very abstract, and barely no one talks about it, because I'm assuming that everyone finds it a bit too much. The modern take. Well, the modern take is very simple. Dependencies point inwards, so the presentation layer is allowed to talk to the application layer, but the application layer is not allowed to talk to the presentation layer, because the presentation layer is unknown to the application layer, because it's outside, and the presentation layer to the application layer is inside the circle. Then, if we look at the domain layer, this layer is also known as the entities layer if you look at the original diagram of IncoBob. And this layer's responsibility is to define entities which contain enterprise-wide business logic. This means that you should be able to take this domain layer and use it everywhere. Now, if you go back one layer up to the application layer, this layer that's application-wide. So in the application layer, we will create an interface for our input-output devices to communicate with. Application layer is also something that we can't really share between different applications because it's specific to this application. Then we have the infrastructure layer. This infrastructure layer contains the database. It contains the event bus. It contains an email service. The whole idea behind this infrastructure layer is to implement the interfaces that the application layer needs. It's also allowed to talk to the domain layer. It's mostly indirectly though. Like, for example, let's imagine your infrastructure layer has a database and it implements a repository from your application layer. Now, this repository is always going to have domain entities. So if this infrastructure layer has an implemented interface, it already knows about these domain entities. That's the reason why infrastructure is indirectly talking to the domain. Then we have the presentation layer. This presentation layer is your entry point for your customers. So it could be a website, it could be a web API, it could be a CLI, name it, right? And this presentation layer directly only talks to the application layer. And in this application layer, usually live use cases. So let's say in my presentation layer, I have a Express web app, and this Express web app has controllers. Then this controller needs to do something, right? It takes in input from the customer. It talks to the application to, for example, a use case. And the application does this thing and returns it back to the controller, which returns it back to the customer. That's the whole idea about this layer. So looking at this diagram, you're probably wondering, well, where the hell is the diagram of IncoBob? Well, as I mentioned, we will be looking at the modern take of clean architecture because the original idea is very abstract and it doesn't per se define clean architecture. Lastly, there's a misconception between domain-driven design and clean architecture. Yes, the whole idea of clean architecture is to work with your domain. But that doesn't mean that you need to do domain-driven design. Your domain could be a transaction script, so that means that your domain entities are purely data classes, and your application layer will actually do all the logic. On the other hand, if your application is very complex, then your domain might actually implement rich domain entities, and then your application layer, where the use cases live, will do less work. It depends on your requirements, and if it's the case that you're doing transaction script, then clean architecture is probably not the right way to do it. But if you were to do transaction script, then if you look at the diagram now, you will see that it makes more sense, right? Because the middle isn't known as a domain anymore. It's known as entities. And the application layer now is known as use cases. If you look at this diagram, you wouldn't really say, well, I'm going to do domain-driven design. Anyway, this is the essence of clean architecture, and you don't really need anything more than this, unless the requirements ask for it, of course. The main component. Well, the main component is something that bootstraps your application. Well, what do I mean with bootstrapping it? Well, something needs to inject those dependencies. A controller needs a use case. So the main component says, hey, controller, here's the use case. And this use case might need an adapter to its interface, right? So it would say, well, this iPrisma repository will get the Prisma repository implementation class. This is the whole idea behind the main component. It just takes the frameworks and controllers, the use cases, all those dependencies, and it links them together, and then you can just run it. Now, sometimes, or depending on the language and your preference, you might use a dependency container. On the other side, some people prefer to do it manually with factories. That's also fine, as long as you know that the main component is where it all starts. It needs to link all those dependencies together in order to run your application. Testability. Testing. Who likes testing nowadays? Well, I do. And the biggest reason I started to like testing is because of architectures like clean architecture, hexagonal architecture, onion architecture, because they all really focus on dependency inversion principle and dependency injection. With those two principles, you can create components that are decoupled from each other. And if they're decoupled, testing becomes easier. Now, we as TypeScript developers are very lucky because we do not really need to define interfaces to test something. If we look at a language like C#, if we wanted to test a class and it had a dependency, but it wasn't an interface, then we couldn't really mock it. Considering we are TypeScript developers, we are lucky, so we don't really need to use interfaces. Even though for your mental picture, it might make more sense to just put an interface there. Because the idea of clean architecture is to build around a plugin architecture with the dependency inversion principle, you can also utilize something called a test API. This test API has superpowers. The idea behind this test API is to know everything about your application, just like the main component. So let's say I have a test case, and in this test case, normally I would just say, well, make a HTTP request to this endpoint, and I expect that this endpoint returns this. Okay, cool. But what if I wanted to confirm more things? Then I would say, well, if I had a dependency container, well, get me this database, and I would just do a query to see if something got inserted, which is fine. But the problem is, when we change this database, your test also breaks. And this is kind of the idea of a test API. This test API is this facade, which knows everything about your application. And in your test, you could say, well, test API, can you confirm whether this record got inserted? Well, yes, I can. And the beauty of it is that if we change our database now, which rarely ever happens, by the way, that the test breaks, but it doesn't break in the actual test case. It breaks at the test API. So if you have like 20 tests using the test API, we only have to change it at one place. But if you have 20 tests and they all talk to that database and we change it, now 20 tests break, even though the test might actually be valid. So because of it, we get some stability into our testing suite. And that's essential to keeping a very healthy testing suite, in my opinion. Well. Component principles. No one ever talks about it. It's mentioned in this book and even in this blog, but I've never really seen anyone, well, on YouTube at least, talk about it. I really don't want to talk about it either, because First of all, I don't like the idea of principles in the sense that you might think it's a rule, but it's not a rule. And some of us understand them differently. Therefore, I would just recommend you to go to Google or get this book. And this book, it's in page 103, I think, where he starts talking about them. And just study them for yourself. Get an idea of what he means with those component principles. And utilize them when you think you need to utilize them. Clean architecture is actually very similar to hexagonal architecture, but it has one extra layer. Of course, there are a few different mindsets to each architecture, which I don't want to get into, but I just want to show you how similar it is. If you look at the diagram on the right, on the top we used to have presentation layer, but in hexagonal architecture, it's the driving adapters layer or the input adapters layer, whatever you want to call it. Then when we get into the shell, we used to have the application layer, but now it's core. And where the hell is the main layer? Well, in hexagonal architecture, you just merge them together because, well, let's be fair, you're never going to use that domain library and use it in a different application. But when you do, then you need to look into clean architecture, in my opinion. If you look at the last layer called driven, which is driven adapters layer or the output adapters layer, this is the layer also known as the infrastructure layer. It has the repositories. It has the email services. In my opinion, if you look at this, then I would rather opt for hexagonal architecture compared to clean architecture because it's simpler. Why do I need that extra layer? I don't care. I'm not going to use my domain layer in a different project. Now, before I finish my rant about clean architecture, well, not really a rant, but it's abstract, right? So let's look at this concept, vertical slice architecture. After a few years, people started to realize that clean architecture is very hard to maintain. Let's say you needed to add a feature. Well, I need to go to the domain layer. I need to change this entity. I need to add an enum. I need to change this type. I need to add this type. Okay, now let's go to the use case. Oh, where is it again? Oh yeah, in the application layer. 2000 files, where is it? Okay, found it. Now you need to make changes there. And then, oh well, this adapter also needs to be implemented. Then you go to the infrastructure layer and so on, so on, so on. Which was, you're just all over the place. Plus, it really promotes merge conflicts because, well, your teammates are probably also working in the folder, right? So vertical slice architecture came, which has also quite a few implementations. So I'm just going to show you two of them. And it said, well, what if you just took a slice of it? Let's just put everything that belongs together. So if you look at the first folder structure on the left side, we have a folder called cars. And this cars folder has a folder called domain. So in my domain could be the car entity, the car color, enum, whatever. And then I have a folder called features. And in this features, I have everything related to the application use case. So selling a car. Selling a car could have files like sell car use case. It could have the DTOs. It could have the database implementation. It could have the repository implementation. It could have everything related to that sell car use case, which makes it really cohesive. And that's what we want. We want everything that belongs together. Now, if you look on the right, we also have an implementation of vertical slice architecture, which tends to get recommended too. Is instead of going towards that feature style, we will just take we will take our clean architecture and put it in a folder. So now we create a folder called cars, and then we put down clean architecture in there. So you have the main application infrastructure presentation, but it's less, it tells me less about the application, right? And that's also something very important that Inka Bob talked about. Your architecture should be screaming. It should tell you what it does. Now, on the right side, it tells me it has cars, customers, and reports. If I look on the left side, it actually tells me it has car, sell car, view car. But on the other hand, I still need to go 2 folders deep to look at it. My thoughts and misconceptions. Well, clean architecture has too much indirection for my taste. It depends on your requirements. But like I said, let's say you have a domain which you want to use in different applications, and clean architecture makes perfect sense. Or if you have a very rich domain, then clean architecture might actually also make sense. But if you don't, then you're creating indirection for what, right? And clean architecture also defines those rules, principles that say, well, group them by technicality. Your controller should be in the presentation layer. Your use case should be in the application layer. Your database should be in the infrastructure layer. Your controller should always talk to use cases, but it shouldn't really talk to your database. But what if I just wanted to do a query? Am I really going to make a controller, a use case, an implementation in my repository to just get some data? Why shouldn't I just use my controller and say, hey, controller, just use this repository database directly and return the query? It's hard to be pragmatic in clean architecture. That's why I dislike the idea of those architectures. Yeah, it's up to you, right? I also mentioned briefly that your architecture depends on requirements, so don't get too hung up on clean architecture. Remember its ideas and use them when you think it's needed. Don't make abstractions without purpose. That's the main idea. Also, clean architecture doesn't per se mean domain-driven design. I've seen so many people talking about domain-driven design. Hey, I'm learning domain-driven design. Hey, I'm learning domain-driven design patterns. Where I'm like, well, what the hell do you even mean? And then eventually they end up with clean architecture. Those two are two different things. Yes, there's a strong appeal between clean architecture and domain-driven design, but it doesn't mean that you need to do domain-driven design. Also, don't forget, domain-driven design is more than the technical patterns. There's also a whole strategical idea behind it, and that's the most important thing about domain-driven design. So yeah, clean architecture doesn't mean domain-driven design. Besides that, I recommend you to read the book, understand the original version, maybe implement it, and then just remember the ideas. Don't get too hung up on it. Lastly, dependency injection frameworks versus factories. You don't need a dependency injection framework or IC container, whatever you want to call them. You can also use factories. It's whatever you prefer to bootstrap your application. But if you ask me, a dependency injection framework makes everything way much easier, because you don't have to implement something to deal with life cycles. Let's say a dependency should be a singleton. Then in a dependency injection framework, I could say, well, this is going to be a singleton. What if I want to also always pass the current request data? Well, then I could say to my dependency container, well, inject this in a request scope. You can't really do that with factories without a lot of manual code that you have to write. Let's go to the live example. So in this example, we are going to be looking at a logbook application where we have two use cases to implement. The first one is creating a logbook, and the second one is getting the logbook. So before we get started, notice this file, which is called main, which is actually our main component. If I run it, you'll see that it bootstraps the application, which at the moment is only a console log, and says hi. So to get started, we're going to create a few folders. So we have the domain layer, right? We have the application layer, we have the infrastructure layer, and the presentation layer. Now, what I usually like to do is start at the application layer. Definitely when you're working in a transaction script like way, because there's not much in your domain, right? So let's start here. We're going to create our first use case, which is going to be create logbook use case. And let's create a class. And this class is going to have one method, execute. And a use case should generally always have an input and an output. So, well, actually, that's not completely true. It could only have an input or even not have an input, but generally it's input output. So, what do we need to create a logbook? Well, let's see, interface. Create logbook video. We want to know the user ID, and perhaps we want to give it a name. So let's pass this here. It's called input to make it clear. And for the output, we need to return something, right? So I create logbook result, and this result is going to have the created ID, I guess. And we pass it. So I create logbook result. Right now it's going to complain because we are not returning it yet, right? And let's get started. first, what do we need to do? Well, we need to create a logbook. So let's start making a logbook. Let me close this. Okay. And it's going to complain because it doesn't exist. So let's create it. And we said that it would have a name and a user ID, right? So constructor, let's give it the name and a user ID. And an entity should really also have an ID. But to make life simple, we are just gonna generate an ID, then we create one. Okay. Now we have this, and now it expects us to have some arguments. So let's give it the name, we give it the user ID. And let's also, let's see, can we make this happy? Because it keeps complaining now. Let's just give it return logbook ID for now. So it actually formats. Yeah. So we have this, and now we need a way to store it, right? So if you think in clean architecture, in order to store something, we need to talk to an input-output device. So in this case, the database. And as we know, the database lives in the infrastructure layer. In order to talk to the infrastructure layer, we should use dependency inversion principle because we are not allowed to know about layers outside of application, right? So we would need to define a contract. So interface I logbook repository. And this repository is going to have a save method, which takes in the domain logbook, and it returns either it returns either true or false. Just to say, well, it's saved or not. There are many ways to do this, but to keep it simple, let's just return a boolean. Okay, so now we need to utilize dependency injection. So you're going to say, give me the repository. Okay, cool. Right now, I can go in my execute method and say, well, repository, just save the logbook. And give me the result back. And if the result is false, then we throw an error. There are many ways to handle errors and exceptions, but we are just laying down the skeleton of clean architecture, so let's just keep it simple. And if it works, then we return the logbook ID, because, well, you create a logbook, and on the front end or in your terminal, you might wanna get the created logbook, right? Okay, now we have this. And as you notice, we didn't even touch any details. Like we didn't touch the database, we didn't touch the controllers, we didn't touch Express. But yet we have quite some logic written down already. But it doesn't work yet because we need to go to the infrastructure layer. But before we do that, let's just quickly move the logbook to the domain. So let's say move to a new file. And let's move it to the domain. Do we have something else that we need to move, or is everything here? Well, we could move this, the interface, just to a new file. And that should all be good now. Let's give it a quick save all, because I don't trust VS Code. And let's go to the infrastructure layer. In the infrastructure layer, we need to implement the interface adapter. So for the time being, I'm going to use an in-memory logbook repository. So let's create a class. And this logbook repository needs to implement that interface, right? There we go. We get the save method. And notice how it knows about the logbook, which lives in the domain. That's what I meant with an indirect connection with the domain from the infrastructure layer. Now, this is very simple because we only need to store it here. So let's do a collection of logbooks and just simply push it in. So in this case, it's always going to work. And make it async. Awesome. So now to the presentation layer, because we have created our domain entity, we have created our use case, we defined a contract for the database, and we also implemented an in-memory repository, which we will later on replace with Prisma. So let's go to the presentation layer. In the presentation layer, I'm going to create the server, so API server, and let's call it API server. And let's install Express, because we need Express, and also its type since we are in TypeScript. Let's import it. Let's just make this static for now, just to keep things simple. Let's give it a run method. We pass it the port and the use case that it needs. So now the controller that it needs, right? Let's not get too far ahead of ourselves. Let's say run. The run is going to be async. Public static async run. And let's create the app. Express. Considering this is a JSON API app that use, we also use the middleware. That's, oh damn, writing is hard. Jesus. And let's pass the port that the console log server is running. Cool. Let's go to the main component because we're not done yet, but let's hook up the things you have already, right? So we have the use case, which is a new create logbook use case, which expects a repo. So in memory repo. Pass it in. Notice how we are like linking dependencies now. And well, what is missing? The server API. API server, I call it, server API. Run and give it a port. We can now wait it, but it doesn't really do anything. Let's run it. Oh, the server is running, but we are not exposing anything yet, right? So let's go back and go to the presentation layer and create a controller. So I like to create separate controllers for each use case, but you could also have one big controller which acts as a facade to that talks to all those use cases. Okay, so let's call it create logbook controller. And this controller is going to have one method, handle. It takes in the express types because it knows about the framework. And it returns void. So the controller is in the presentation layer, which means that it knows about the application layer. So we can actually inject the use case. Read only use case create logbook use case. And let's call it here. Use case execute input. Now what does it need? It needs a name and user ID. Okay, so name is going to come from rec.body.name. And in user ID, well, we don't have any alt yet, so I'm going to create a fake user. Cool. I'll wait it. It gives us back a response. And considering it's always going to work now, we're not going to worry about what happens if it doesn't give us a response. You're just going to say rest.json response.logbook ID. Oh, let's make it an object actually. ID. We'll get back to this in a second. And let's also give it a status of 2.1, right? We just want to see it work. Are we missing something? Not yet. So, okay, API server. The API server now needs to get that dependency. So we're going to pass it here. Create logbook controller. And we're going to bind it. So it's going to be a post in logbooks, which gets the rec and res. Controller.handle rec res. Now, if we go to main, we can hook up that controller. Const controller equals new controller. Let's hope it comes. Yeah, there we go. IntelliSense for the win. Pass the use case, and now give it the controller. Now, if we run it, and we open up our client, we go to logbooks, make a post request, it should work, as you can see, but the application is still in an invalid state, right? We are not giving it any data, so right now the logbook title or name is actually defined. So what you should do, or well, one way to tackle this is to do input validation at the controller level, which is something I prefer. You could also do it at your application layer. In the use case, you can do the validation here. Well, you pass this input, and does the name really exist? But that to me sounds weird, because, well, from the controller to the application, I expect that the data is already validated. It should be there. And then inside my use case, I will do some business validation, which is different. But in this case, we're not going to do the validation. I just want you to know that if you need to do validation, you can do it either in presentation, application, or even in the domain layer. So for now, we are just going to pass it proper data. Is there something else that we're missing? Well, if you look here, the controller is not really giving us a concrete DTO that we can return to the client, right? Like there's no contract. We're just saying, well, you get IT response logbook ID. So to fix this, we have two options. We can go back to the application and look at this result and treat this as our DTO. So if we go to our controller, you could say, well, export class created logbook DTO, or whatever you want to call it, which implements we didn't export it, right? No, we didn't. Let's export it. I create logbook result. And now we can implement it and use it as our DTO. We can also add decorators. We don't have it, but it's not API server, it's API property. So for example, if you're using Nest.js, they have in a package for Swagger for OpenAPI, where you can decorate your properties with API property, and then it gets added to Swagger. And the benefit of that is that you can actually generate an API client out of those DTOs for your client. But we don't have Swagger, so we're not going to do it. Now, there's one way to define our DTO. If you're only going to make an API and nothing else, then to me, this is fine. Because if something changes in my application, the presentation should also change. But if I had multiple delivery mechanisms, let's say I would have an API and I would have a CLI, then I would actually separate those DTOs. Then I would say, well, export class, create a logbook DTO. Let's remove this one quickly. And not implement it, because now I'm just going to make a static method, say static method, say static from the result. So result, I create logbook result, and it returns a created logbook DTO. Now I can actually define the properties for this DTO without really being bound to the interface. So when something breaks, I can still maintain the same contract at this level. But it's not worth it because I'm only making a REST API. So therefore, I'm just going to say, well, I will just implement that interface, and everything that changes in the application will go back, will also bubble up to my presentation. Okay. Now we have this. The controller works. We have an API server, which is not the nicest one, but it works. We have an in-memory logbook repository. We have a logbook, the contract, and a use case. Okay, so we have our repository implemented as an in-memory logbook repository. But now we're going to dive into this plugin architecture, because I don't want to use an in-memory logbook repository. This means that whenever I restart my application, my logbooks are gone. So let's utilize Prisma. So let's close the server and say yarn add app Prisma client. We should also init Prisma, I think, if I remember correctly. I don't use Prisma that often anymore. Yarn, what is it? npx Prisma init. Oh, look at that. Auto IntelliSense. Yes, proceed. Awesome. So I think we have Prisma installed now properly. Let's see, Prisma schema. Yeah. So let's define our SQL database. Model, we have a user, but we are going to ignore for now. We're just going to do a logbook. So the logbook has an ID. Oh boy, how does this work again? Like this? Things like this. Right? It has a name and it has a user ID. Well, normally we would put a relation here, but just for simplicity, we will keep it like this. And let's run yarn prisma migrate dev, or just do migrate dev. Let's create a migration. Prisma not found. You know what? Here you go. Who cares? Yes, generate it for me. Okay, so we have a migration which has, for the time being, a one-on-one relation. It's the same as our domain entity, but you could imagine that later on the SQL database schema might actually differ from your domain entities. But in this case, it's just the same, right? Okay. let's go to our infrastructure and create a Prisma logbook repository. Repository.ts class Prisma logbook repository. And I should implement that interface again, right? And say public async. Okay, what now? Well, we need to use Prisma. So let's see if I can do it like this. This is going to be very sloppy. You shouldn't do this in production, of course. Let's put it here. Oh, we could actually do this. Let's make it a bit better. Let's give it the client. So now there's no, we are not creating a new Prisma client each time we call the repository, which also means that when you need to write tests, you actually have control over the client. Okay, so we take the client and we say, well, we want our logbook. And we call create, which takes in data ID, which is logbook.id, name, logbook.name, and the user ID. So essentially, we're actually mapping the domain entity logbook to the Prisma schema model. Well, we could get the, oh, did I write our way twice? Holy shit. Okay, so we got the result, we could do something with it, but I'm just gonna assume for now that it always works. Right? And there you go, we have our Prisma logbook repository. Now if we go to our main component, notice how I'm not going to the use case, because the use case just expects a simple contract, nothing else, right? So now we need to instantiate the client and our new repo. Prisma repo equals new Prisma logbook repository, which needs the client. Notice the dependency injection going on? And now we can just replace this in-memory repo with Prisma repo. Let's see if we can still run our application. Server is running. What happens if I make a request now? I'm wondering. So let's go to body and actually give it some data, right? So it needs a name. My name. It needs the user ID. Oh no, we don't have to pass it in the body, I think. Do we? Let's see. Perhaps I made a small mistake before. Let's see. No, it's fine. Okay. So we have our Prisma repo set up. And now when I send a request, remove this, send, it's created. Later on, when we create a second use case, we can actually verify if it exists. But I noticed something. Perhaps you already noticed this before, but we created this DTO, but we are not really using it, are we? If I look at this, the JSON body is just still using the old contract. So what I want to do, considering I can't remember if Express has the types here. I don't think so. So just let's do this response. What did we call it? Create logbook DTO. And then we create it. Create it, logbook DTO. And this create logbook DTO should also take in a constructor, which gets the ID, right? And now we can pass it, which is going to be, let's call this result. Logbook ID. And instead of doing this, you can just give it the response. So now we actually respect this contract. Okay, awesome. Now, up to the second use case, which is getting a logbook. Get logbook use case. Just like before. And to make life a little bit easier, I'm going to define a contract for interfaces, for use cases. So interface our use case, which takes in an input and also an output, which has a method execute, takes in the input, and output is always going to be async. Now we can actually use this But before I do, I will create a shared kernel. This is a place where we can just put things that are like completely shared. Our use case. Okay. So we have this. So now let's go back to our application. And before we continue, let's tell this use case that it needs to implement the interface, which takes in the iCreate logbook.to as input and the iCreate logbook result as output. And let's do the same for the new use case. So now we don't have any type, so I'm just going to do any, and generate the method. Right? So what do we need to get a logbook? Well, we only need the ID. So let's create an interface for it. I get logbook DTO, which is ID. Put it here. And as result, we return either the logbook or nothing. No, wait, that's wrong. We are not allowed to return the domain entity. So we should probably define a DTO for logbook. Let's create it. Logbook DTO. And this logbook DTO comes from the domain entity. Logbook. And now we can actually define the properties that we want to expose. So we want to expose the ID and the name. And then we just map it here. Logbook DTO, logbook ID, no, yes, and logbook name. And the result is going to be a type. Well, we don't actually need to define it. We can just say logbook DTO. And let's regenerate this. And as you can see, we have to find our contract. Now the only thing we need to do is get the logbook, right? So public constructor. Private read-only logbook repository, logbook repository, and call this logbook repository and say, well, find the input ID, which is the logbook ID. Notice how it's not even implemented. So if there's no logbook, well, then we throw an error. And if there is, then we just return the logbook. Do we? Let's see. Let's continue with repository. I might be wrong. Implement this find method, which should return the domain entity, right? Okay. While that's happening, we need to go to infrastructure and implement them. So in here, in the in-memory one, we need to return the logbook. So return this.logbooks find where the ID equals ID, otherwise return null. This could be that it doesn't exist. And should be async. And well, that's that. And for the Prisma logbook repository, we actually need to talk to the database. So we say const result equals await this.client logbook, what else? Logbook find unique where ID is ID. If no result, actually don't remember what unique does. Does it throw errors? It does it for us. So we could just say return. Actually, no, that's not true. So it returns either the Prisma logbook or null, right? So if no result, then we just return it. Because, well, our contract states we should return null if it doesn't exist. Otherwise, we should return the domain entity. For the time being, if we just do this, it should work. Because, well, in TypeScript, it checks how an object looks like instead of what it actually is. So for now, it would say, well, it's the same object, but it really isn't. So we need to map it. So we need to say, well, return a new logbook. And this logbook should be result.name, result.user ID, result.id. Now it's mapped to our domain entity. Okay, I hope that made sense. Now we can go back to presentation and create a new controller, which is get logbook controller. Which has a method, right? Public async handle, takes in rec request, press response, and it returns nothing because we are on express land. And this controller has a dependency on a use case. Which takes the ID, so rec.body.id, or however you want to pass it. And we just simply return another contract, right? But what is it going to be? Well, just like we did before, we could take the interface or DTO from the application layer, which in this case is actually the logbook DTO, which is already mapped from the use case. So in that case, I could just do result. Now bear in mind, consider this is an API. We could actually do a little bit of transformation here, because perhaps I would like to send something like this instead, which might make more sense. But for the time being, to keep everything simple, we just return it like this. Okay, the main component. Now, we need to create the dependencies again, right? So const, let's call it get controller equals new get logbook, which needs use case. So const get use case equals new get logbook use case, which needs the repo. We already have it. Here's my repo. Takes the get use case. And now we need to pass it here, because it needs to set up the route. Let's see if it's smart enough. Probably not. Or does it do it with, no, it doesn't do it with a line variable. Okay, so I need to do it. So we go here, get controller, get logbook use case. No, sorry, get logbook controller, remove the use case. And we just bind it again. Get controller, and there you go. Now, if we run the app again, it's still running. Let's just restart it. Expect I'm unable to compile TypeScript. Okay, and why is that? What have we missed? Main.ts. Seems fine to me. Let's do save all. And run it. Server's running. Nice. Let's create a request. My name 1. Send. And take this ID. And let's just paste it here and give it the ID. Let's see. Send. And there you go. It gave us the created logbook that we recently created. Now, if we look at all of this, you would say, well, that's a lot of work. Well, yeah, I agree. And for queries, which we just did, it just feels really cumbersome. Like, look at what we did. We created a controller. If we go to the use case, the only thing we did, we talked to the repository to get some data. And then we also had to map it, which we actually forgot, because TypeScript is, again, a really pain in the ass when it comes to comparing objects. So we actually need to fix this. Logbook DTO from, what is it? Logbook, right? Now it actually returns the proper type. There are ways to get around this, but I don't want to get into that, considering we're just talking about clean architecture right now. But if you look at this use case, there's a layer of interaction that doesn't really make sense to me. Like, we're getting data from a bit database and we're mapping it. Why can't I just create a database and have it map it for me, right? So you could say, well, screw this. I'm not going to make a new use case. I'm not going to do that implementation in my repo. I'm just going to call them a controller, which to me is fine. But because we are in clean architecture land, it feels wrong to put something that's related to the application in your presentation layer. So, and that is why I talked about the vertical slice architecture, and also Ingo Bob mentions it in his book. I think that's the reason he does. So if you just commit this quickly, oh, there's no Git repository yet, so init, git init, let's see, git commit, clean arc1, and let's move it around. Let's give it a name, logbook, and in logbook we could say, well, presentation, there we go. Now we're closer to vertical slice architecture, but the problem still exists. If I go inside logbook, it's like, well, I don't want to make this use case in repo just to get some data. And this is where the second variant comes, in my opinion, and it's also the better one. Is where I just say, well, you know, I have my domain. I might have a shared folder, but everything else is just around my use cases. So create logbook. And everything around create logbook is there, infrastructure, the repo. I would want to put it there, but it's shared at the moment, so I can't. Domain, I'll keep it in domain. In the application, create logbook use case. Okay, put it there. Yeah, and then just keep moving stuff. Okay, now let's go get logbook. Get logbook use case, put it in there. Get logbook controller, put it in there. So if you open the get logbook, then it makes more sense, considering you are not really limited to the structure of clean architecture. Right now, I'm happy to say, well, use case, I will just remove you and I will do everything in my controller. But clean architecture, it's kind of steering you towards technical grouping instead of the actual logic. Now, even though I've moved quite some stuff, there's still some things that we need to consider, right? Application still exists. What the hell is this doing? Well, it's shared, so I'm just gonna make a folder called shared, and we'll just put it in there. Okay, application layer can be removed. Domain I want to keep, because domain to me is important and is always shared between everything. You could argue to put it in the shared list, whatever you want. Infrastructure, well, it's all shared. Presentation, well, it's only the API server, let's put it there. Now we can remove this. Okay, very close now. But now, there are a lot of shared things in this folder, and I could consider some other principles. Like, for example, if I go to create logbook, it depends on the iLogbook repository. But I could also say, well, instead of iLogbook repository, why don't you depend on I create logbook, which has the same contract, right? Logbook, promise boolean, and then instead depend on this interface, which should still work because the repository might implement this interface and have this method. It's not necessary, right? Because this all makes sense already. So yeah, that's clean architecture in a nutshell, and I really hope that this makes sense. Now, of course, I left out a lot of details. Might be a little bit confusing because I did this live without a real plan. But if you have any questions, feel free to hit me up on YouTube. I will make sure to reply on every single question. And yeah, good luck.